Hello and welcome everybody to my talk about pushing the limits with React PHP. Subtitle is Why React PHP is Awesome, and I hope I'm going to show in the next couple of minutes why React PHP is awesome, and I hope you agree. So what can you expect from my talk today? I'm going to give a very short introduction into PHP in general, into why React PHP is special, but the main part is actually the examples and demo types. So everybody who has a laptop in range is encouraged to pick it up, and I'm going to invite you to my demo. Everybody who does not have a laptop, don't worry. You can still enjoy watching what the other people do. So, welcome. Again, hello. My name is Christian Lück. And because that funny character there in the middle, many people have problems with it. I usually go with Lück with UE. And that actually makes up for my initials. That's why I am Clue on GitHub. And unfortunately, my Twitter handle GitHub, Clue was free on GitHub, but it was already taken on Twitter, so that made me another Clue. So in case, in case you're wondering or want to tweet my talk, reach out to another Clue. That's me. So I could introduce myself, but I don't think this is really interesting. I have an academic background. I have worked with PHP for over than a decade, but I think what's most important to know about me is that I am actually passionate about doing what I do. So I do this talk because I think it's really awesome and people should be aware of this. And this is my motivation for this talk. This leads me to my next step. I am nowadays a freelance software engineer. I used to work for more than 10 years in a professional environment, and I quit my job last year in order to focus on things I am passionate about. So this is my chance to you to reach out. So much about me. Now let's get to you. Who are you? You know me. Who here is a PHP developer or architect engineer? Raise your hand. Okay, that's pretty much everybody. That's a good thing, I suppose. It's, after all, the DPC and not the JPC, or the DJC for JavaScript. So who knows about React, the React with this logo? Okay, raise your hands, don't be shy. About half of you. Okay, so I'm sorry, because if you're here to learn about React, I have to disappoint you. This talk is not about React, it's about React. And throughout this talk, I'm going to call it React. You can also call it React PHP. You can either call it the other React, or if you ask me, it's actually the real React, because we had the name first. And this was like 5 years ago. React.js wasn't a thing back then, but nowadays things look a bit different. Yeah, too bad. So this is React. Now let's look, how is PHP usually used? PHP is usually used. So PHP was invented in the 90s, and the web looked totally different like 20 years ago, or almost 30 years ago. We had like a very traditional request-response cycle. You send an HTTP request and get an HTTP response. You have your client that uses Apache, it uses PHP, and it accesses some database, for example, MySQL. This is a very traditional, average, normal stack, and you still end up with something very similar to this nowadays. People often criticize PHP for being too slow, but of course we can improve this stack. This is a very cheap stack. We can improve it, for example, by using FPM. So we can run multiple PHP processes in parallel. We can, for example, use Nginx instead of Apache. Or we could, for example, use Memcache to offload our database so we don't hit it all the time. So this means, well, PHP may be slow, but let's face it, we can actually, it's not pretty, but it gets the job done. We are here because we work in an environment with PHP, and we earn money with it, so it can't be that bad. So we can work around its quirks. But nowadays, knock knock, who's there? It's not the 90s anymore. Nowadays we have 2017. And the demands have changed. Nowadays we have separation of concerns, things that weren't an issue like 20 or 30 years ago. We have a front end, we have a back end, we have integration with third-party APIs, we send HTTP requests to third-party APIs. We want live data, for example, a chat example, or our current stock usage, for example, anything. We want to push this to the browser, and this wasn't a thing back then. And we have CLI tools. So when we think about live data, a lot of people think about Node.js, because Node.js is pretty much made for this. And this is a valid option in my opinion. You can use Node.js, but then again, this is DPC, so how about using Node.js? I would suggest using Node.js. It's already in the name, so I think nobody can disagree. Sorry, couldn't resist. Okay, so let's dive into React PHP. What is React PHP? Let's get into this really quick. So let's just get out the buzzwords. It's non-blocking I/O, it is event-driven, it's asynchronous, and in other words, it's 100% pure PHP, it has no extensions, and that means it has no magic involved. You can install it on any system that runs PHP, and you get 100% pure PHP and runs everywhere. So, but then again, what does that even mean? Let's dive into this. How does it work? The idea behind React PHP is actually very simple, and it can be expressed in like 2 sentences. The idea is calculations are very fast. Your CPU is freaking fast, but then I/O is very slow. And what this means is, unfortunately, I/O is everywhere, which means your CPU may be fast, but you can't really use it because you always have to wait for input-output operations. And input-output is everywhere. Whenever you're accessing a third-party API, which is obviously input-output, you're sending a request to a remote server, but also when you're using a local database. If it's in a remote data center, even if it's on your local machine or your local network, you still have to transfer data in and out. And even when you're using the file system, when you're storing files on your system or even a network-attached storage, you still have input-output operations. And you may not even be aware you're using this because of session files, for example. They usually, by default, reside on the file system, so we end up with input-output operations without even noticing this. And one of the first slides suggested using something like a cache daemon, for example, Redis or memcache. But then again, even this server still involves input-output operations to send the request and receive the response. So input-output is still everywhere. So how can we solve this? The CPU is really fast, input-output is really slow. In numbers, this looks like this. You don't have to see every single number, but the main takeaway here is if you look at the top numbers, this is what happens within the CPU. It's measured in nanoseconds. And when you're transferring data through the internet, you measure this in milliseconds. And there are several order of magnitudes between. This is a huge difference. So the idea is basically we have to accept the fact input-output is slow, and this is not going to change. But why wait if something is slow? Why not do something else? And this, in short, is the very idea of React PHP. You start multiple operations, non-blocking, and then whenever something happens, you do something. And this means you don't have to waste any time waiting. You only execute something when there's something to do. So this is React. A very short introduction. So let's look into what React is not. When many people look at React for the very first time, they have an idea what React could look like. And it's not some kind of black magic voodoo. It doesn't work on its own. You have to use its paradigms. You have to get used to it. You have to introduce it into your infrastructure. It doesn't work on its own. It's not a framework. You don't just install it and it runs. It's a set of components that have to be used within your use case. And this also means it's not going to replace your existing architecture, your existing ecosystem. You have to use it alongside your existing Symfony stack or whatever you're happy with. And in other words, it also means React is not going to disappear anytime soon because it's already like 5 years ago. It started 5 years ago. We had our anniversary like 2 months ago. Yay, 5 years. So this is going to stay. Okay, so much for the introduction. If we want to dive into React PHP, there are essentially a number of core components, and then everything is built on top of this. And this is going to show up in every of the demos that we are going to see later. So there are essentially 3 main components. The first main component is the event loop. It's the low-level component. And when you're using it, it has very simple semantics. You create it once, you pass it around, and you start it once. And you don't care about it. That's it for the loop. No more details about the loop. create, pass around, and start. That's it. And in code, this looks like this. You create it, pass it around, and run. And this is going to show up in every of the examples. Internally, it implements the reactor pattern. If we want to get into technical details, we can start timers. For example, get the notification when something happens. This example is going to print out, obviously, hello world, because the times are going to execute in the time when they expire. And we can also get notifications when something interesting happens on a stream, but this is not something anybody's going to use because there's a higher level abstraction. And this abstraction is streams. Streams are an abstraction for everything. Think of a file download, think of a TCP/IP connection, everything where you can send data or receive data. This means there's either a readable side or a writable side, or it's duplex in case it's both. In code, again, only very short. It looks like this. You can set up, you can write to the stream because it's an object, and you can get notifications when something happens. And so much for the streams. This is actually very powerful. It looks like very little code, but because this interface is used throughout the whole React ecosystem, it allows some pretty powerful things, like the lower line here. You can use a source stream without diving into details. We get an understanding of what this does. It pipes it into a unzip filter, so it extracts the contents. The extracted contents gets passed into a bad words filter, so bad words get filtered out, and the resulting stream gets piped into a destination file. The source could be an HTTP stream. The destination could be, for example, a file on your local disk, or it could be anything else, essentially. This is streams. But let's face it, streams are still a bit difficult to grasp, so there's a higher level abstraction, promises. Promises are not really a new concept for most people, I think. Who has worked with promises, for example? Okay, that's about 50%. The short version, it's a placeholder for a future result. It's used, for example, in JavaScript world everywhere, and there's also an implementation in PHP, and the short version, it works exactly the same, and you can get a notification when a promise is ready. This means an operation is either pending, or it is fulfilled, or it is rejected. It doesn't switch any other state, so it can't switch from fulfilled to rejected. Once it's fulfilled, it stays fulfilled. And in code, this looks like this. You have a promise in this case, and then when something happens, do execute this function. For example, in this case, start the process function when the result is there. So this is promises, and we're going to see this in the examples applied. So, okay, so much for the technical stuff. You made it through the hard part. So let's get our hands dirty in the examples. Okay, so when you first start with React PHP, or even if you start with Node.js, one of the first things you're probably going to bump into is a socket server. It's the canonical example of how to process data. A chat is essentially a broadcast. You can send messages to it and you get a message back. And when multiple people connect, you get all the messages back. So I've prepared a very simple socket server demo, and you can use Telnet if you have your laptop in range to connect to my server, which I have to start. So you see I'm not cheating on you. The example is bundled with a socket component in this case, and I started on port 6002, and you can connect through this address, I hope, if the Wi-Fi. Let's give it a few more seconds, and I think it's not going to work. Let's make this really hard. Okay. Kill. This is the thing with live demos, obviously. Okay, in this case, let's hope for an SSH connection. Unfortunately, the conference Wi-Fi does not allow direct connections to my laptop. This is running on my laptop, so I'm using a port forwarding into the internet, so you can connect again to my laptop. And this means I rely on the internet, and I don't have internet access right now. So this means I'm going to chat with myself. No problem. I can still start a chat on my local host. And wow, surprise, surprise. When I send a message hi in this case, okay, I hope you can still see this. Anything I type on my keyboard ends up in every window that's connected to this chat. So once the connection is up again, you can also send me messages. Let's hope for the internet. Perhaps it's going to work in a moment. Okay, so this is a chat example. So how much code does this involve? Let's look into this chat example really quick. There's missing a bit of the output. Okay, only the really short version. Again, like I said, you start the loop once at the top, and you don't really care about the loop. You start the server. In this case, it just runs on port 0, which means a random port. And then lower here, whenever a connection comes in, this is an event when something interesting happens. And when data comes in on this connection, we just remove some wild characters in case anybody's trying to mess with the demo. And then we iterate over all connections and send back the data. This is essentially a chat example. And this is everything. And then at the bottom, there's the loop run. This is it for the chat example. Again, this is a very low-level component. It's not really interesting, but let's get into making this more interesting and hope for the Wi-Fi to come back again. I think it's, yeah, people managed to connect. That's great. Let's see. My server's running and see if people can connect. Did anybody manage to connect? Yeah, okay. Yeah, finally. See, people can actually chat, so this actually works. Whew. Okay. So, but then again, this is still the terminal. It's kind of boring. Let's get this into something more practical. So this is the socket server. This is a very low-level TCP/IP connection, but most people probably don't want to mess with the low-level TCP/IP stuff. Sorry. What's more interesting, for example, is an HTTP client. You can send an HTTP request to a remote server. You're probably, if you do something like this, you're probably going to use Guzzle. There's a fair chance you're going to use Guzzle. There's also an alternative. It's called Bus, and there's a binding for Bus in React. This library is called Bus React. And it's essentially PSR7 compatible. So if you're used to working with normal PSR7 request and response messages, you can use this, and things just work magically, but you can execute multiple requests in parallel. But again, internally, this uses everything we've just learned. It uses an event loop. It uses streams to process the HTTP messages that get sent, and you get a promise back whenever the result is there. And I promise you it's fast, but I'm not going to show yet how fast it actually is, because let's face it, again, HTTP is really low level, so let's skip this. There are a number of benchmarks. What's more interesting is when we start integrating with a third-party API. In this example, I've chosen to, or picked Packages API. Packages is a central repository for Composer. That means you can send a package name to it and you get back information about this package, like a number of downloads, for example. And this is kind of like a high-level API where you can send information or query information from. And this uses the HTTP client. It's a very simple wrapper, and this is a very nice showcase to see how these things actually work together. So if we go to the Packages API, we can execute an example. It's called search, and we see some output. If we execute this again, we see some output again, which is good. Let's look into what this example does. So how does React PHP look like from a user perspective? Again, you start some boilerplate code, you start your loop, or you create your loop, you create some instances, and then you start a search call. And then when the search result is ready, do something. In this case, I'm just dumping the results. And what we're seeing here is I actually execute multiple functions. Yeah, there are two characters are missing. There's obviously client. So client get, and I send multiple queries in parallel, and whenever something interesting happens, I react to them. And interestingly, I start the search first, but if you look at the output, the output was over here, the search result returned last, which is obvious because the search is going to take much longer than querying a single package. And we don't have to care about this because this is handled internally, and you can react when the result is there. So this is the packages API. What's more interesting, there's also a Docker API. Who has worked with Docker? Okay, this should be more hands, I think. The short version, it's kind of like a VM, but it's not. Don't ever say it's a VM. It's totally different because it's container. It allows you to ship software, to bundle software within a container. And these containers are really lightweight and really fast. And the idea is I can ship this container to any system and run it. This is the idea. And yeah, it's an idea. And the interesting thing is if you install Docker on your laptop, you actually end up with a Docker daemon that's running all the time and it doesn't have anything to do. And this Docker daemon has an HTTP API, and we have just seen an HTTP client. So how about using the HTTP API to control Docker? This means we can use PHP or React PHP to start Docker containers, to interact with Docker containers, like get information from them. So in code, this means, for example, we can, get some information from my local Docker daemon. Whatever it's going to print, it has some version number of containers, anything. And this looks exactly like the examples I've just executed. Some boilerplate at the top, and then I'm going to execute client info, and when something happens, print out the results. This is boring, let's face it. What's more interesting is let's start a benchmark. The thing is, we can actually send data to a container, and we can receive data from a container, so we can measure how fast we can receive data from a container. And this is not going to work because I have not started a container yet. And this means I'm just going to start a really small busybox container, so it doesn't do anything at all. And the benchmark executes just a dd command that prints 1 GB of data. So when I first ran this benchmark, before I ran this benchmark, I had an idea of what kind of values you get back from running a benchmark. How much data can you process with PHP? And the result, I think, is really interesting because it's 650 megabytes per second. It's not megabit, it's megabyte. So this means we can transfer about 5 gigabit per second within a single PHP process. And the interesting thing about this, last time I ran this was around 700, okay? My laptop is busy, obviously. The interesting thing about this, when you look at the benchmark and you check what your CPU is actually doing, you see that the Docker daemon is actually hitting 100% CPU usage and PHP is not. This means, in other words, Docker daemon is maxed out and PHP is not. Or in other words, PHP is faster than Docker. So the benchmark would result in a higher number if Docker would be faster, but it's not. So only 700 megabytes per second, but I think it's still a very interesting number. What would you transfer with 700 megabytes per second on a single CPU on my very mediocre laptop, i3 CPU, nothing special. So much for the client side. Let's switch to the server side. We've seen an HTTP client. How about we start an HTTP server? There is the React HTTP project. It is a pure PHP server, so you don't have to install an Apache, Nginx, whatever. You can just run this, and it uses, again, standard PSR7 interfaces. So if you're used to, for example, Slim framework, this is going to look very similar. It doesn't provide all the nifty stuff around because it's not a framework, it's a library, but the core messages look exactly the same. There are a number of third-party integrations into existing frameworks like Slim, Symfony, for example. And yeah, I gave away the number. Too bad. Okay, let's pretend this didn't happen. So how long is, if you perform a benchmark against your local Apache web server, how many requests per second can you execute? Let's assume your page is really fast. It's only going to take like 10 milliseconds, sorry, 10 milliseconds. This means you could execute around 100 requests per second on a single process. You can obviously scale this horizontally. You can spawn multiple PHP processes. So let's just say 1,000 requests you can execute on my laptop. It's very cheap, dual-core CPU, nothing special. But if you run this benchmark against the React PHP server, you receive around 5,000 requests per second, which I think is a very impressive number. I've prepared a benchmark for this. We can run this later. Trust me, it actually works. And the thing about this is actually only using a single CPU on my laptop. I have a dual-core CPU, so I can actually execute 10,000 requests per second. And what I think is really interesting about this number is, let's do the math. What does it mean? 10,000 requests per second. How many requests per hour? I first gave this talk at last year at T3 DD, and there was somebody from Google, and he had a talk. I think the title was somewhere like serving 30 million requests per hour from the Google Cloud Engine. Was a really interesting talk, but it did the math, and what actually came out here is I can run on my CPU 36 million requests per second. So this means my laptop outperforms the Google Cloud Engine. Okay, it's a synthetic benchmark, and I only print hello world. But again, I'm faster than Google. I think we can just leave it like that. So again, very interesting numbers, I think. But we still try to show a chat example in the web browser. So let's get our web browser so we can see this in the demo. Let's get into server-send events. Server-send events is also known as event source. Who has worked with event sourcing? Who has worked with event source, which is not the same thing? Okay, I see one single hand. That's good. I've never seen anybody raise his hand. Okay, nobody knows about event source. Event source was established kind of parallel to WebSockets, and it has a very similar use case. You can stream events from a server to your browser. That's the main thing. But it's not bidirectional like a WebSocket. You can send and receive data. Servers and events are only unidirectional. You can only receive data from the server. But if we want to send data, we still have AJAX, for example, so we can actually run it in a separate data channel. It has decent browser support, which means it runs on any browser except if it is from Microsoft. They have no support at all. There is a polyfill, and it has very good support, and it supports all the features used in this demo. So let's see what this demo is going to look like. Again, I'm going to start the demo. And this very simple demo is going to run on port 6003, and it's going to connect to my other server that's still running in the background where people keep sending messages to it. So let's open the browser. We are DPC Clue Engineering 6003. If the Wi-Fi is still there. If it's not, I'm going to chat with myself again. Let's see if doesn't look like it's still there. Kill it the hard way. Okay, no Wi-Fi. Again, let's chat with myself. No problem for me. I'm a split person. So this is the chat example. It's a white screen, and I don't see anything at all. But if I go to the Telnet console in the background and I send hi, and then open my browser again, there's hi. And obviously it would be way cooler if somebody would send a message to the chat. But let's look at how much code does this example involve. So if I show the source, this is it. You only start an event source. It's a native browser object, and when a new message comes in, create a div and append it to the body. So this is obviously a demo. It's not very pretty. So like I said, I gave this talk last year again, the first time, and somebody approached me after and said, hey, you can't keep this like this. How about I prepare a nicer looking demo. Sorry, stop the wrong window. So there's also example number 11, sorry. wrong language. So if I'm going to reload this again on port 603, this time it's a beautiful chat, I promise. So there's a window, and my name is Chris, and hi. So the chat actually works. If you look at this code, there's a bit of JSON decoding, there's a bit of JavaScript for emitting the proper events, for hiding form input, and some styling, and that's it. Again, let's see if somebody manages to connect, because it would make it much more interesting. But if it doesn't work, yeah, it's working. You can connect.
I'm connected to it, but it's not putting it through Wi-Fi.
Sorry?
Like I'm connected via hotspot and that's working, but
I'm connected to my server. That's what it said at least, but okay, you're right. I'm not connected. 603. Okay. I promise it does work. I've just presented it on my laptop. Let's see if we want to look at this later. Perhaps it's going to work when the Wi-Fi is more stable again. Okay, no problem. So much for servers and events. We've seen the client side. Let's look into the server side in the meantime. If we're going to look at the example, it's again really simple. Example number 2. Again, some boilerplate, and then when an HTTP request comes in, attach it to a channel, and then here at the bottom there's when we connect to the chat server, and whenever data comes in, send this data to the channel. This is the whole chat example. It's a single file. It's part of the examples. You can download the demos, you can download the repos. They are part of the distribution. So this is everything you need to create a chat example. And the other chat example, the beautiful chat example, doesn't even use a separate chat server. It's all built in. So if we look at example number 11, it looks very similar. We have kind of like a router-like structure. We return certain responses for these paths. And we have here, when a new message comes in, we write this message to the channel. So this means everybody's going to receive this message. And when we access the chat, it's here, we just connect the response to the channel. This means the response is going to receive everything you send to the channel. And this is the whole code which you need to build a chat application. Again, this is using JSON messages. This is a chat example because you can reproduce it locally. This is obviously only structured data. You can transfer any kind of data. In this case, you can transfer your current prices, your news blog post, anything you can think of, you could transport through this protocol. Okay, let's get back to the presentation. So much for servers and events. Like I said, servers and events is an alternative to WebSockets. There's also a WebSocket server implementation. It's called Redshift. If you're using WebSockets with PHP, there's a fair chance you're already using Redshift. Has a bit better browser support, but it's a way more complex project. So the demo would look pretty much exactly the same, except more code. That's it. Okay, so much for the servers. Let's get into databases. So in the early examples, I gave the idea of using a memcache or a Redis. So in this case, I'm going to use a Redis client. Redis is a very fast database. Who has used Redis? Okay, more than 2/3, I think. So you know what Redis is. It's really fast, but it is very limited. That's the basic idea. Very simple commands. And this also means it has a very simple protocol. And you can send a request and you get back a response. That's the short version of Redis. There's a Redis client available. And I have prepared a very simple demo. And this demo is called increment. And when I run increment, it's going to increment a number, obviously. So let's look at the code. Again, it's a very similar structure. You start a loop once, you create the client, you increment a number, and in this case, I'm going to get the number after incrementing, and then when the result is there, I am going to process it. So I'm going to print the result in this case, and then stop the loop. This is what React PHP is going to look from the client side. So this is the Redis client. Who knows what language the Redis server is written in? Or any guess? There's a, hey, sorry? It's not. It supports Lua, but it's actually written in C. So why would anybody write a database in C? It's not obvious. C is really fast, and other languages are not. Or are they? Because the official Redis server is written in C, but there's also a re-implementation in pure PHP. This is a link, you can click on it. I don't know who wrote this server. No, seriously, somehow I ended up writing a Redis server when I tried to test my client, and I realized, oh my God, this is really simple to write a Redis server, so I ended up writing a Redis server. So the end result is you can use a Redis server written in PHP, which is very simple to add new commands, because it's essentially using reflection and a public function, and every public function you add, if you want to see it, I can show it later, it's going to take a bit longer. You can add any number of functions and they get exposed through the Redis protocol. So you can use your existing clients to actually talk to PHP without exposing this is PHP. But then again, how fast could this possibly be? Who would, in the right mind, would write a database server in PHP? But we've seen some benchmarks already. And when I performed these benchmarks for the first time, here are the numbers. I actually received about 50,000 requests per second, and the official server on my laptop received about twice as much. This means a single CPU on my machine is about half as fast as the official Redis server. Again, I have a dual-core PC, so I could actually outperform the official Redis server, which is still running on a single CPU. Okay, I'm cheating. But I think it's still really interesting, because we are still talking about 50,000 requests per second, and there are a number of use cases that don't involve these numbers at all. If you're only accessing or using it as a cache, you access it once for a web request, you probably don't end up with 50,000 requests per second, because your HTTP server is probably not going to be fast enough. So this is some really interesting number. And you can see this in this demo. I actually didn't use a real Redis server. I actually used my PHP implementation. And if I stop this, and execute it, it's actually not going to work anymore. So this is actually my Redis PHP server that's been running below. So I would not really suggest you ditch your official Redis server implementation and replace it with a PHP implementation, but the numbers are still interesting, and the key takeaway here is who needs native code anyway. So if you ever end up in a situation where you consider writing a new database, consider using PHP. Just an option, and I'm joking, obviously. I think the real idea here is what I've created from this Redis server is a Redis framework. It's still in development preview. I only work on it when I'm at conferences for some reason, when I commute to conferences and back. And what this could result in is a very simple example that looks like an HTTP router. So it looks like a Slim framework, but it actually processes Redis messages, and you can react to any message with any kind of response. So if you integrate this into your existing environment, you have your existing Redis clients, you have your existing applications that use Redis, but you don't really have to use Redis on the other side, as long as it behaves like a Redis server. And this makes it really simple to write a new Redis server, and in this case, let's see what this looks like. Okay. Workspace Redis framework, and I've prepared an example that's called beer. And if Wi-Fi works again, I am connected. you may be able to order a beer from my Redis server. Let's see if this works. DPC clue engineering. Connection refuse. Okay, in this case, I'm going to connect locally again. And if I send hi, it says, okay, make it a bit smaller. Sorry, but we only serve beer. If we send a ping, it's not a valid message. But if we manage to send the beer command, we get a beer. And the cool thing about this, we can actually use any kind of business logic. In this case, I've introduced some timers so you can order too much beer. And once we run out of beer, this example is going to stop serving beer. So this shows how this can be used to implement custom logic. There's also an example that uses the existing ping commands or get and set commands. And if you look how much code is actually involved with get and set, I think it's really interesting to see how Redis actually works under the hood. Again, there's some boilerplate at the top. And then here's our router. If we receive a get command, we simply access our array. In this case, it's called storage, which is defined above. So here's a storage array, which is empty. And when we get, we read from this array. And when we send the set message with 2 arguments, we just set a key in this array. And this is essentially what Redis is doing under the hood. Obviously, the official Redis implementation is a bit more optimized. This is a very simple implementation, but this is the core of what Redis is doing. So it's really simple to add custom commands to this. So because I'm running out of time, I've prepared plenty of demos. If you want to see more of these demos, just come to me and we'll look into each demo as long as you want. So there are a number of other applications. For example, there's a new PnP client, so you can detect which devices are on your network, like your local printer or multimedia devices, Chromecast devices, for example. It uses a promise-based API. Obviously, there are unlikely to be any printers or Chromecast devices on this network, so the example can be skipped. But there's also a cool thing called Zenity. And Zenity allows you to build a desktop graphical user interface application with PHP. And you should definitely check this out, because there are a number of examples. And the first example actually says this, because you're going to end up in hell if you're building a graphical user interface application with PHP. The very short version, just to show what's possible. Zenity React example. This is what a graphical user interface application built with PHP could look like. You could choose your test environment, you can choose a license which you have to agree, or you can use some data, interfere with some third-party application. Please don't do this, but you can. Okay, so much for Zenity, and this means it's the last letter in the alphabet. We are done with the demos. There are many, many more projects. This is just trying to give you an idea of what is possible. Please check out the users wiki. There are a number of things not covered in this presentation. So let me just recap really quick. The thing is, React is a real deal and is here to stay. It is production ready. It has millions of installations. It has thousands of installations per day. So it has a predictable release cycle. It is production ready. You can use it, and I encourage you to consider using it. But let's face it, it's not magic. You have to invest time in it, and I think this presentation is trying to show you can benefit if you invest time in this. And the idea is basically, whenever you have to wait, consider using React PHP. Whenever you're accessing anything over the network, consider using React PHP. Don't use, maybe not use, but consider using React PHP. That's the main point here. And the result is PHP is way faster than you probably thought. PHP is more versatile than you probably thought. And if you need help, come and talk to the React PHP team. There's also, I'm not alone here, hi. Check out the README, check out the homepage. We have React PHP Twitter handle and hashtag. or talk to me, because did I already mention I'm available? I'm a freelance software engineer. Talk to me. So thank you for your attention, and I encourage you to come to me, talk to me. I also have a bunch of React PHP stickers with me, so you get an official approval of certified React PHP developer. Thank you.